Synthetic division is a shortcut for polynomial division that only works when the divisor is in the form x minus k. So this would not work for a divisor like x squared plus 5, for example, right? But if our divisor is of the form x minus k, we take that number k and put it on the outside of this bracket, and then we take the coefficients of the polynomial and put them on the inside. When I say the coefficients, I really mean the numbers only, no x's in here. Also, set this up with a little bit of space here. We're going to be able to write one row of numbers below those coefficients before we get to the bottom of this bracket. So let's go ahead and set up this first example. If that divisor is x minus k, then that suggests to me that k is equal to 4. So I'm going to set up my division bracket with a 4 on the outside, a tall bracket that has room for 2 lines, and just write the coefficients of the polynomial on the inside. 2, negative 3, negative 12. Now, the first thing I do is I just drop the 2 down and write it below. Every time I am going up, diagonally upward, I multiply it by k. So every time I'm doing this move, I multiply the number I just found by that value k that's sitting on the outside. So in this case, 2 times 4 is going to give me 8. Now, every time I am going down, and this is one way in which synthetic division differs from polynomial long division, every time I go down, I add. I don't subtract. I just add the numbers with the signs that they've got right there. So negative 3 plus 8 gives me 5. Now I'm ready to again go diagonally up, which means that I multiply by k again. So 5 times 4 gets me 20. And I am again ready to add downwards. Negative 12 plus 20 gives me 8. Now here is how I read off my results. That 2 belonged to x squared, that 3 belonged to x, and that negative 12 was my constant term. When I read off my answer, everything is shifted over 1, by which I mean that 8 is my remainder r, that 5 now becomes my constant term, and 2 becomes the coefficient of x. If I had more terms here, the next one would be x squared, the next one would be x cubed, etc. I would just keep increasing the degree by 1 as I read off to the left. I'm only going to consider the ones I have, though, which gives me this result: 2x plus a constant of 5 with a remainder of 8. And I'm going to express my answer the same way I would if I had found it by polynomial long division. My quotient is 2x plus 5. My remainder is 8, so I'm going to write this as plus 8 in the numerator divided by my divisor, which was x minus 4. So what we really find is that we have a remainder, which we can identify here, remainder. And everything else makes up the quotient. So that's where I got my 2x plus 5. 2 is the coefficient of x. 5 is my constant term. Let's look at another example of synthetic division. This one has some missing terms. With synthetic division, it is especially important to represent those missing terms as zeros. Remember that when we set up that bracket, all we are writing is the coefficients, meaning all we're writing is the numbers that are associated with those powers of x. If I leave out these two zeros, then I'm treating this as if the polynomial were 3x squared minus 7x minus 20. It's implied that every position is represented. So these missing terms, it's even more important with synthetic division than it is with polynomial long division. These missing terms must be represented by zeros. So I will set up my bracket, and starting with 3, the coefficient of x cubed is 0, the coefficient of x squared is negative 7, the coefficient of x to the 1 is 0, and then the constant term would come last. Now, if my divisor is x plus 2, and I'm saying that that needs to be of the form x minus k, then that suggests that k is equal to negative 2, because I can make x plus 2 look like x minus negative 2. So there is always a sign difference in between what my divisor looks like and what my value of k is. So over here on the left, I'm going to put negative 2 and then start my process. Every time I go downwards, remember, I add. Except in the first step, I'm not adding anything at all. I just go ahead and drop it down. Every time I go diagonally upward, I multiply by k. This one's going to have some signs in it where the other one really didn't. So multiplying 3 by negative 2, I get negative 6. Then adding downwards, 0 plus negative 6 is negative 6. Again, going diagonally upward, negative 6 times negative 2 gives me positive 12, and adding downward, negative 7 plus 12 is 5. Diagonally up again, 5 times negative 2 is negative 10, and adding downward, 0 plus negative 10 is negative 10. Going diagonally up again, negative 10 times negative 2 is positive 20, and coming down, negative 20 plus positive 20 is 0. So it looks like I got a remainder of 0 in this case. And if I get a remainder of 0, I can also say that this divides evenly. Another thing that tells me is that x plus 2 must be a factor of that dividend polynomial. But we will go ahead and write our quotient. So we already identified the remainder. The next term over is the constant. Then I start with my x's. X to the 1, x to the 2, x to the 3. Noticing that we always end up with a polynomial that is 1 degree lower than what we started with after synthetic division. So this polynomial is, the quotient is 3x cubed minus 6x squared plus 5x minus 10. And there's no need to write plus remainder over divisor. if that remainder is 0, since that whole term is going to turn out to just be 0. So this is my quotient, and it's the only thing I need to put in my answer.